Welcome. Today I will be discussing the rules that we use to finding the function of the derivative. Remember in the last video I kind of showed the rule, the definition of derivative, which is f prime of x, which is the function of the derivative, equals the limit as h approaches 0 of f of x plus h minus f of x over h. And this is what we call the definition of derivative. But we find that we were able to find the derivative of a bunch of general functions, very common functions, using this rule of derivative. I will not actually go through the derivation of finding these rules because a lot of them can be very involved algebraically and geometrically, but I will show you the different rules in this video. So to start, we will start with what we call power rule. And this covers basically any polynomial or like kind of rational function you might have. So it states that the derivative, where d dx means take the derivative of whatever function is here. It's kind of the infinitely small change in of this function divided by the infinitely small change in x. So the derivative of a times x to the n, where a and n are some constants, it does not matter what constants they are, equals a times n times x to the power of n minus 1. So let's say we had f of x, and that equaled x to the fifth. So that's a polynomial expression right there. You could say that f prime of x would actually equal 5 times x to the fourth. You multiply by this top power, right? You multiply by this power, and you subtract 1. And that's it to the rule. And a little side note, this goes for really anything, not just power rule. You can take as many derivatives of the function as you want. So to notate that, you just add a second slash, and you would call this you call this function f double prime of x. And that is the slope for any value of x of the function f prime of x, which is the slope of f of x. It just keeps on building off of itself. And what you get is 20x to the third if we take the second derivative of this first function, or the first derivative of this derivative function. And actually, with any kind of polynomial expression like this, what you end up getting, the more and more down the line you go, is that some derivative will equal 0. And any derivative after that will also equal 0. But that's not what we're here today. We're focused on the rules of derivatives, so I'll kind of get off this tangent, if I will. I just want to make sure that you were aware that you can take as many derivatives as you want. There's almost no end to this. So I just want to show you one more example. Actually, I'll show you two more. So let's say we had 9 times x. So we know that x is actually the same thing as x to the first, right? The 1 does not change the value of x. So this power rule still applies. We multiply by 1. This time the 9 stays through, much like how a stayed through there. 9 and a are the coefficients of x. but then we multiply by x to the original power minus 1, right? We end up getting 9 times x to the 0. Well, we know that x, or any value for that case, the power of 0 is 1. So we're just left with 9. So whenever you have a coefficient times just x raised to no power, well, technically power of 1, the derivative of that function is that coefficient, which actually should make a lot of sense. If you think of, remember what a derivative is, it's the slope of that function. So if the function is linear, like 9x, that means its slope is constant. And in fact, that slope is equal to that coefficient of x. Think y equals mx plus b, right? F prime of x is m in that case, when you have a linear function. So that is power rule. I hope you had a notebook there because I'm about to delete it all. This is a video too. You're able to rewind as much as you want. So next we're going to get into a bit more complex functions. Some functions you're probably more likely to see in Algebra 2 and Pre-Calc. So we will start with e to the x rule. And we say that the derivative of, we got a coefficient here, so some coefficient times e to the x actually ends up equaling that coefficient times e to the x. So the function e to the x is actually unchanged by taking the derivative. And you could say that the function e to the x is the function of its slope. So that's I always thought was a very interesting rule. And it's really weird to think about, in my opinion. But I just want to make sure that it's also made clear that this only applies for e to the x. E, if you don't know, is a constant referred to as Euler's number. It's used a lot to describe population growth and exponential growth like this. And I want to say it's around 2.71, something like that. That's supposed to be a 1, not a weird star. That's generally what it's equal to. It's actually an irrational number, much like pi. It's a bit lesser known though, but just know that the derivative of e to the x is e to the x. And any constant that you had carries over too. So related to that, we have the function ln of x, the natural log of x, which if you don't know, it's just log base e, right? I hope at this point you understand what a log function is. But if not, just know that log base e of x equals y means that e to the power of y would equal x. It's kind of the inverse of this exponential function. So we know that the derivative of a times ln of x, again, a is some coefficient. I just want to make sure that it's clear that any coefficients kind of carry over as you take the derivative. So a times ln of the x equals a, I'll write it like this, times 1 over x. I write like this, you can write a over x, it doesn't matter really. But ln of x, the derivative of ln of x is 1 over x. So that's the ln over x rule. Both ln of x and e of x were pretty simple, pretty straightforward. So next we have our sine and cosine functions. And I'll actually loop these in kind of the same rule because they're very similar, but there's one little technicality that makes it a little tricky. I'll show you just a second. So the derivative of the function sine of x, that trigonometric function, is actually equal to the function cosine x. So cosine of x gives us the slope of sine of x for any value of x. And that's, I think, is a very fun and actually a very easy to remember rule. It's kind of fun to think about those two kind of waves being a function and its slope. But if you were to take the derivative of cosine of x, find that slope for any value of x, you probably want to say that it's sine of x, wouldn't you? But that's not entirely true. What we actually end up getting is negative sine of x. Oh, that's a pretty harsh eye there. So we end up getting a negative sine of x, and that's that kind of like technicality that can be hard to remember sometimes, and it will trip a lot of people up. But it's so important that you remember that it's negative sine of x. And again, I forget to write it in, but any coefficients outside of the function carry through, just like that. And you can actually keep doing this. Like, let's say we were to take the derivative of negative sine x. That's not supposed to be there. That's an improper equal sign there. So we have sine of x, or sorry, negative sine of x, and that equal, you probably guessed, negative cosine x, right? Because that coefficient carries through, even if it's just negative 1. And do that one more time. Take the derivative of that last derivative. So we take the derivative of cosine x. And I hope you kind of guessed at this point, we would get sine of x, right? Because those negatives kind of cancel out. And we're left where we start. So I think that's a really interesting thing, is that if you keep taking the derivative of a sine function, you end up where you started. So that's all the major rules of differentiation, which I should let you know is the process of taking derivative. We say differentiation. These will cover a lot of the functions that you need to know to take the derivative of, but there will be some functions that are a little too complex to use these general rules, and I will cover that in a later video. But that's the gist of it. Thanks for watching, and keep learning. Keep wanting to get a good grasp of calculus, because it's such an interesting math subject, and it's truly like no other. But I think it's so worth it to actually understand the concept and not just go through it trying to get a good grade. But thanks for watching.